law in electrostatics. So here if I take two charges, either it is a positive charge or two negative charges, and r is the distance of separation between them. So in place of q I take q1, and in the place of q I take q2. Here I take q1 and q2. So this I have written like this. Either they may be either same charges or there are different charges. It may be plus q1 and minus q2. So either of these, and r is the distance of separation between them, then the force of attraction or repulsion between the two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance joining the two charges, or F proportional to q1 q2 by r square, or F can be replaced by a constant known as k into q1 q2 by r square. So k, the value of k is approximately 9 into 10 power 9, and this value is given by 1 by 4 pi epsilon 0, where epsilon 0 is known as permittivity of free space. So if I substitute F is equal to, in place of k, 9 into 10 power 9 q1 q2 by r square. So the units of force is newtons. The product of q1 q2 is Coulomb square, and the distance r square is in meter square. So this is how you find the force of attraction or repulsion between two charges. This is known as Colulomb's law in electrostatics. I can tell you one thing. Suppose I want this Colulomb's law in vector form. I want Colulomb's law in vector form. So how do I take this? I take here O, X, Y. So X and Y axis I have taken, and I have taken two charges Q1 and Q2, and I have taken R2 is the position vector for Q2 and R1 is the position vector for Q1, and R21 is given by R2 minus R1. Now I have two types of forces here depending. So F21. So the first number represents on, the second number represents by. So this is F21, force on the second due to the first charge, and F12, this is the force on the first charge due to the second. So this is given by 1 by 4 pi epsilon naught into Q1 Q2 by R21 square into R21 cap. Similarly, F12 is given by 1 by 4 pi epsilon 0 Q1 Q2 by R12 square into R cap 12. These are charges Q1 and Q2. So this is F21 and this is F12. So if both are same charges, then their direction is like this, and it is a repulsive force. And if Q1, Q2, so if it's an attractive force, it's like this. So at that time, F21 is equal to minus F12. So this notifies Newton's third law. So every action there is an opposite and equal reaction. Next one is intensity of electric field. Electric field. So intensity of electric field is defined as E. So it is given by the letter E and it is given by the letter F by Q. So that the force that is acting per unit positive charge placed at a point in the field is known as intensity of electric field, and the units are Newton per, the units for force is newtons and the unit for charge is coulombs. So Newton per coulombs is the unit for electric field. Now, I have a derivation for the intensity of electric field. So I take two charges Q and Q naught. If R is the distance of separation between them, then according to Colulomb's law of, you can write this formula as 1 by 4 pi epsilon 0 Q into Q naught by R square. So if I take F by Q naught, so this is given by 1 by 4 pi epsilon 0 into Q by R square. So F by Q naught is nothing but E. So E is equal to 1 by 4 pi epsilon naught into Q by R square. So this is the equation for intensity of electric field. Electric line of force it is used to visualize electric fields. So what is the definition for electric line of force? It is an imaginary curve or line drawn in space when a tangent is drawn at one particular point for that curve or line. It gives the direction of the electric field. So one thing we must think over here. So this is the definition for electric line of force. So electric lines of force for positive charge are always away from the charge. So this is how electric lines of force are being represented. And for negative charge, they are always towards the charge. So suppose this is electric charges. There are some properties for this electric line of force. Electric lines of force, first property is they start from positive charge and end at negative charge. Second property is they are always perpendicular to the surface. Third one is electric lines of charges do not form closed loops, means these lines of force do not form closed loops. Next, third one is electric lines of force, we cannot have two directions for electric lines of force, because when we draw two tangents it gives two directions for one. Next one is in continuous charge distribution, when there is a region like that, they do not form continuous loops. So these are the four properties of electric lines of force. Positive charges, suppose I take positive charges like this, the electric lines of force are represented like this. Now, if I take a positive charge and negative charge, travel like this. So these are some of the properties of electric lines of force. What is meant by a dipole? A dipole means two equal and opposite charges that have a certain distance of separation between them represents a dipole. Next, what is dipole moment? Dipole moment is given by the letter P. It is given by one of the charges into distance of separation between them. So this is known as dipole moment. Next one is, I want to find an expression for torque acting on a dipole. So I take a dipole, it is minus q and plus q. So this is the uniform electric field E. So distance of separation is 2a, and here I extend like this by means of a triangle, and theta is the angle which the dipole makes with the electric field. So this is nothing but electric field. So here I want to calculate the torque acting on a dipole. So the expression is here. So two charges separate, this is separated by a distance 2a, this is the electric field. So for this, here two forces will be acting upon minus q and plus q. The force acting on this is q into E, and the force that is acting on this also q into E. So these two forces, two equal and opposite forces, will give rise to what is known as a couple. So for that couple, we have the torque formula is given by one of the forces into perpendicular distance of separation. So I name this triangle as A, B and C. So one of the forces is Q into E into perpendicular distance of separation is A into C. So this is the perpendicular distance of separation. Now how do I write AC? So I want AC from the triangle ABC. So for that I take sine theta. So sine theta, this is opposite side is AC by hypotenuse is AB. So I will write it as 2A. So this gives 2A into sine theta is equal to AC, and I substitute torque tau is equal to Q into E into, in place of sine theta I substitute, in place of AC, I substitute 2A into sine theta. So torque tau is equal to, I write 2A and Q together. So 2A into Q into E into sine theta. So 2A into Q will give me dipole moment. So P into E into sine theta. So torque tau is equal to P cross E. So this is the torque that is acting on a dipole. So for this I take two charges minus Q and plus Q which are on the same line, and it is a parallel line. The actual line is, so 2A is the distance of separation between them, and I take the center of this dipole as O and A, and I divide it into A and A, and I write here as A upon B, and this is C. And in place of C I can take either C or P, but for the convenience of students I take P, a point. So near the point a unit positive charge is placed. A unit positive charge is placed, that is which is at a distance R. Which is a distance R from the center of the dipole. So here I want to find the expression for it. So first I take this is x direction. So positive x direction. Now I take here, you can take it as either E1 or E minus Q. Means the electric field intensity for E1 is given by, or you can take it as E minus Q. I use the formula Q by 4 pi epsilon naught into R square. I use this formula which I have derived previously. So I take it as Q by 4 pi epsilon 0. I want this distance AP square I want. So AP whole square. So this is given by Q by 4 pi epsilon 0 into AP square. So this is R and this is A. So it becomes R minus A whole square. So R minus A whole square. So this is R and this is A. So you want AP square means you have to take this is next one. E plus Q. Q by 4 pi epsilon naught into R square. So this becomes Q by 4 pi epsilon 0 comes q by 4 pi epsilon 0. This becomes r plus a whole square, because this is r and this is a. So ap square means r plus a whole square, and q by 4 pi epsilon 0. Next is bp square, bp whole square. That gives q by 4 pi epsilon 0 into bp square means this is r and this is a. So r minus a whole square, r minus a whole square. Now, or this can be written as E2. Now we have a doubt over here which one to subtract from the other one. So here the numerator is less, so the denominator will be more, and here the denominator is more and the numerator is less. So you subtract E2, so total intensity E is equal to E2 minus E1. So this can be written as q by 4 pi epsilon naught into r minus a whole square minus q by 4 pi epsilon naught r plus a whole square. Now you take out q by 4 pi epsilon naught, you take out common. So you get 1 by r minus a whole square minus 1 by r plus a whole square. 4 pi epsilon naught into, I take r plus a whole square, the LCM here, I take r minus a whole square into r plus a whole square. So this is the LCM. So this becomes r plus a whole square minus this goes r minus a whole square times. So this gives E is equal to q by 4 pi epsilon naught into, so this becomes a plus b whole square. So r square plus a square plus 2ar minus of r square minus a square minus 2ar divided by, so this becomes r minus a whole square into r plus a whole square. So this becomes a square minus b square whole square. So E is equal to q upon 4 pi epsilon 0 into, so this r square and this r square gets cancelled, a square gets cancelled. So 2ar minus 2ar minus of minus 2ar gives 4ar by r square minus a square whole square. So this becomes E is equal to q by 4 pi epsilon 0 into 4ar. So here a square is less compared to r, so this becomes r power 4. So r gets cancelled, so this becomes r cube. Q by 4 pi epsilon naught, 4 by epsilon naught into 4a by r cube. So E is equal to 2 into 4aq can be written as 2a into q by 4 pi epsilon 0 into r cube. So E is equal to 2 into 2a into q gives P. This is nothing but dipole moment by 4 pi epsilon 0 into r cube. So, this is the expression for electric